Okay, so now we are getting into the deep internals of Kafka, talking about partitions and segments. So we know that topics are made of partitions. That's the base. But partitions are made of segments, and each segment is a file. And I promise, segments are made of nothing else. Okay, they're files. So here's what it looks like. We have a partition, and actually there's going to be a segment which has a starting offset and an ending offset. Then we'll have another segment with a starting offset and an ending offset, and so on and so on. The last segment is called the active segment. It's active because it's still being written to. So basically, as the writes happen, they will be added onto the segment. Then when the segment is closed, basically the final offset will be determined and a new segment will be opened. So at any time, only one segment is active. That makes sense, right? This is the only one the data is being written to. Now, it's one segment is active, obviously, per partition. So there are two settings to basically control the size of the segments. The first one is called log segment bytes, and that's the maximum size of a single segment in bytes, and by default, it is 1 gigabyte. And then there's log segment millisecond, which is the time Kafka will wait before committing the segment, so closing it, if not full. And by default, it's 1 week. So how do we understand this? First of all, segments come also with two other files, which are called indexes. And the first index is an offset to position index, which allows Kafka to be able to understand where to find a message in a segment. And then finally, there's a timestamp to offset index, which allows Kafka to find messages with a timestamp. Therefore, Kafka knows where to find data in constant time. And from where it finds data, it starts reading in sequence all the rest of the offsets and the log, okay? So Kafka, though, is not good for random reads and random writes, okay? It's just good for sequential. Now, we have our segments and our partition. And basically, as I said, we're going to have a position index 0 for the first segment 0, and so on, position index 1, position index 2, position index 3 for all the other segments. And we also have a timestamp index 0, etc. for all the files. So basically, our segments are made of different indexes, etc., etc. Now, how can we verify that? So remember how we had our data in the data Kafka topic folder? Now we can see that all these folders, basically in that folder, are our partitions. So for example, for our first topic, we have partition 0, partition 1, and partition 2. Same for our tweets. Like for example, here we have the 6th partition of our Twitter tweets. So if we have a look at within a folder, for example, if we look at first topic, so we'll go to the data Kafka directory, and I will do an ls on first topic and partition 0, for example. And we can see that we have a few files. We have the log. So let me just have this right here. It's ll first topic 0. So we have a log file. This is basically your segment. Then we have an index file to find places in the segment, and a time index, what I mentioned before, which is a timestamp index. Finally, snapshot you don't need to worry about, and this file as well you don't need to worry about. What we need to look at is these 3 files basically are our current segments, etc., etc. Okay, so we've seen how segments are on our file system, but why should you even care? Well, if you set a smaller log segment bytes, for example, less than 1 gigabyte, that means you'll have more segments per partitions. That means that log compaction, and we'll see what log compaction is in the next lectures, will happen more often. And Kafka has to keep more files open, which can be a problem if you have too many files opened. So don't set log segment bytes to something really, really small like 1 megabyte. You will break Kafka. So ask yourself, how fast will have new segments based on throughputs? Basically, if you expect to have 1 gigabyte of data a day, this is perfect. 1 gigabyte of data a week, maybe you want to reduce a bit the log segment bytes. Additionally, there is a smaller log segment millisecond that you can set. By default, it's 1 week. That means that the log will be rolled over every week. So if you set it lower, that means that there is a higher frequency for log compaction. For example, if you set log segment millisecond to 1 day, that means that log compaction will happen every day. But you also get more files, right? So ask yourself, how often do I need log compaction to happen? And we'll see what log compaction is in the next lectures, okay? But this is it for segments And indexes, I just wanted to introduce you exactly to how partitions work. Now you know how Kafka works and you've seen the deep internals, the files of Kafka. So I hope that helps, and I will see you in the next lecture.